Hello. I have finally built an adder. I'm pretty proud of it. So it took me like 2 weeks to do. So basically, what this is part of an arithmetic logic unit, and it can add two signals together, two binary signals. And I'll show you how it works. This was my first iteration of it. This is actually not a complete adder, but this kind of explains the concept well. So on this bottom row is an XOR gate. This is bit 1 and bit 2, basically. So an XOR gate is an exclusive OR, which means that this light will only turn on if it's an OR statement. It will not turn on in any other condition. So if I have a signal here, it turns on, or if I have a signal here, it turns on. But if these are both off or these are both off on, it will not turn on. Now, how the Minecraft redstone works is these torches here will actually power the brick above it if it's not an opaque brick. So when I turn this signal on, you can see this torch goes off, and that turns this one on up top. So the bottom, like I said, is an XOR gate. The top is an AND gate, which means that both of these have to be on for it to output a signal. And this is a carryover. So if I have in binary a 1 plus 0, it'll be a 1. If I have a 0 plus a 1, give me a 1. If I have a 1 plus a 1, then that means the first digit is going to be a 0, and then the carryover goes to the next digit. So in binary, 1 plus 1 would be a 1, 0, right? Now this, I can kind of daisy chain this here, and I can add another signal here and go over. Now the reason why this is not a complete adder is because this doesn't do anything, right? And that is because I did not know how to. It took me it took me forever to figure out where my carryover goes, my carryover information. And what I finally figured out is that I need two XOR gates. So I need the first bit going into an XOR gate, and then my carryover also fitting into that XOR gate. And I'll show you here. You can ignore all this extra mumbo jumbo I got going on here for now. So this is the same thing, but it is a complete adder. So I have an XOR gate here on the bottom. So if a signal here or a signal here turns on, then it will turn that light on. Now, the output of this XOR gate is feeding the input of another XOR gate right here. And then my carryover from my first bit is the other input. So I have two inputs on this XOR gate. My carryover on this bit feeds the next one. My carryover of this one feeds the next one. So just like shown right there, these function the exact same way. So if I have a bit here, it turns on. If I have this one, it turns on. If I have 1 plus 1, that will turn to 2. If I have 2 plus 1, it'll, oops. If I have 2 plus 1, that'll be a 3. If I have a 2 plus a 2 here, that should go to 4, right? So I can add these things together. And just for proof of concept, I put a couple random numbers here in binary. This is a 5 because you have a 1, 2, 4. 4 plus 1 is 5. 6 would be 1, 2, 4 plus 2 is 6, right? So let's add these together. Let's see if it works. So a 5 is going to be an on-off, on-off. So signal A is going to be on, off, on, off. Signal B is going to be off, on, off. So off, on, off. 5 plus 6 should be 11. Let's count it. 8 plus 2 is 10, plus 1 is 11. Sweet. Works. Let's try another one. Reset it here. All right, let's do 9 plus 15. So signal A is going to be on, off, on. on, off, and on. Signal B is going to be on, all across the board. On, and on. 9 plus 15 should be 24. We have 16 plus 8 is 24. Ta-da! My first, I don't know if I'd call it a calculator, but an adder. Yeah, I can add numbers. I know you can do subtraction. I think you can do multiplication and division. I'm not 100% sure, but I know you can do addition and subtraction. Now, what's cool about this though is because these inputs are just yes, no, on, off, right? These are just binary inputs, binary outputs. But they, in binary they mean something. So I can take my encoder that I made over here, and I can hook up the output of my encoder, which is in binary, and have it be the input to my signals here. So I can have an encoder feeding my A input and another encoder feeding my B input. And because I can encode a signal into binary, so if let's say, I don't know, 13 in binary, it's going to be 8 plus 4 is 12 plus 1 is 13, right? So that's binary. So I can hook this up to an adder. I can hook two of these up to an adder on an A and a B side, and I can add numbers. So I could say I want 11 over here plus 7, and it will give me an output just by flipping these switches. So I converted it all into binary, and then it gives me my output, which is freaking sweet. That's way cool. So I understand how it works in my head. Like I totally understand the process, but I'm still going to build it just so I can, I don't know, like commit it to memory. Because a lot of this I'm just kind of learning as I go. So it'll be cool though. I finally get to join the first, one piece of what I've learned to another piece that I've learned, and make something out of it. So slowly but surely, learning the basics of computer processors, and I guess that's kind of what my goal is at this point. It started off being bored and falling asleep on the couch playing Minecraft with my son, and it's turned into a little bit of an obsession. So, but it's fun.